Okay, so this BoF is about new tooling. In the old days, maybe compilers and debuggers were the tools. I was inspired by this by a POC that Rajat sent, which got root within about 10 milliseconds or so of running it. Now I know you had probably even a lot more POCs that could do that, but here's the inspiration behind this. We're receiving a lot of bugs in the kernel from, for me as a TC subsystem maintainer. I always look at them, and some of them will take hours to reproduce. Some of them are just bogus, and I wasn't sure who these people were, right? So that's how this started. So this BoF is to try and gather an understanding of the inspiration behind the people who are creating these tools. What are these tools to begin with? How do they create these bug exploits? And what systems do they use? Hopefully, and lucky for us, they agreed to share with the community. So we'll have a wide variety of sessions today here. So the first speaker would be Shadul, and their tooling is to do stateful protocol flow fuzzing, and they are focusing at the moment on the MTCP, MPTCP, multipath TCP. This will be followed by Rajat, who is going to describe his system for patching and make some recommendations, I suppose. And this is going to be followed by Andrea, is it you or Stefano presenting? Stefano is going to present the asymmetry of this. Folks sending all these bug fixes, finding bugs and then sending probably not so good bugs fixes, and then how much time the developer or the kernel maintainer has to spend time on. And then we're going to have Yuan, who is building a big infrastructure. He's going to talk about his plans for his agent infrastructure that is finding kernel bugs, not slightly different from Rajat. And finally, I guess everybody has heard of Sashiko. We're lucky to have Roman, who's going to be showing up. Unfortunately, he couldn't make it, so he's going to do a virtual talk on Sashiko, plans, et cetera, and I'm sure it's going to be a very lively discussion, and I'm going to start by having Bartol.
Thank you, Jamal. Hi, everyone. So this session focuses on the work we did to extend a fork of syscaller that enables us to reach the hard-to-reach paths of MPTCP that the stock syscaller, the default syscaller, struggles to reach. So just we'll go through the three names quickly because our work is based on this. So for anyone who's not aware, MPTCP or multipath TCP enables us to create multiple subflows or paths for a single TCP connection. And syscaller, most of you are aware of, which is the coverage-guided fuzzer by Google. One thing that syscaller gives, which is relevant to us, is the pseudo syscall features. So syscaller has a program generator and a mutator, which generates a set of test programs, which is basically a sequence of syscalls, and mutates on it based on the coverage information that it gets, and the corpus as well. So it also gives an option to add pseudo syscalls, which is we can have our own sequence of syscalls and decide on how to run them and mutate them. And then there's this BRF, which was an academic project a couple of years ago, which was done by Emery Hung and team. So what they did is they forked syscaller and tried to achieve states wherein BPF could be fuzzed further, because syscaller is not able to fuzz BPF by default. So they added pseudo syscalls as well as BPF features, which is a program generator apart from the syscaller's generator. So it generates BPF programs, compiles into object files, and also has a set of pseudo syscalls that enables them to run BPF open, BPF attach, load, and trigger the BPF hooks, which the generator had created. So we picked up BRF, because we found it to be already have some useful features to address the problems that MPTCP fuzzing had, in our opinion. Right, so let's look at the MPTCP flow. One example where a stateless fuzzer would struggle to get into. So when we want to add a subflow into an already established MPTCP connection, this is the handshake. So when we have to client and server, and we have to go through this handshake in order to achieve or establish a new subflow. So yeah, I mean, syscaller is not aware of this. So it doesn't know that first, before establishing an MP join or requesting an MP join connection, an MP capable connection is needed for an MP join to pass and get a new subflow added. So yeah, a new path is trusted only after a token, then HMAC. So there's a crypto-based handshake. Crypto computing is part of this handshake, which syscaller struggles to pass through. There are some numbers. We have some numbers on the stock syscaller versus the extensions that we made. So syscaller is able to pass this handshake, but the numbers are very low as compared to what we were able to generate. We'll be showing the numbers soon. And another path that was interesting for us was the rejection flow. So like if we look at the first path, this was like syscaller was able to make this request, and through the kernel path manager that MPTCP has, it was also able to achieve valid HMAC, like valid connections, valid MP join connections. But it was not able to create a condition where one of the HMAC is, like if it is false, if it is wrong, then the rejection paths, the syscaller was not able to take those at all. And the valid MP join connections were also very low in numbers, so we'll see those. So what we did is we leveraged the features provided by BRF to add pseudo syscalls so that we can bring up a proper MPTCP connection before we start fuzzing. And through that, we were able to get access to these flows as well, the middle handshake flows, which could lead to the rejection paths. So yeah, I mean, our tool, what it does is it owns both the endpoints, and it does capture the crypto tokens as well, but we are not using them right now. We'll be extending it when we fuzz more of user space PM. And we are able to flip one of the fields. So if we flip the HMAC over here from the server, or if we flip HMAC B here, then the path validation call fails. The HMAC validation, call fails. And we are able to exercise the rejection flows as well. So yeah, as you can see, the HMAC established, both fuzzers are able to reach, but the wrong HMAC, the rejection paths, only the tool that we are extending is able to reach right now. So just one bit flip through NFQ, because we know the connection and we know that the MP join is going to happen, so we are able to, like the executor in syscaller, in our tool, is able to identify the packet with sing ACK packet or ACK packet, and accordingly flip in order to target the mutation that we are trying to achieve. So this we are able to do on demand, and for stock syscaller, it has to rely on random fuzzing to be able to achieve just the valid HMAC. So these are the additions that we did on top of the existing BRF system that was created. So we added pseudo syscalls in order to capture the real token and drive a genuine MP join handshake, and also gain the capability to flip a field to see the rejection paths light up in the coverage. And then we also wrap the HMAC validators plus option parsers so that the coverage is visible. So like currently in the default MPTCP code, the soft IRQ coverage is not available. So the stock syscaller doesn't even know if it is able to cover this or not. So, I mean, we have made some local changes, but we are trying to standardize them so that they can become more upstream friendly. And maybe we'll send the patches so the soft IRQ paths are also added in the coverage. And also the USP that BRF had, which is the BPF being the ability to fuzz BPF. So that also we leveraged. We added the MPTCP struct ops, which is the MPTCP shed ops. And now we are able to generate BPF programs for MPTCP and also fuzz them further. Yeah, so like I mentioned that we are owning both the connections and we are doing a genuine handshake. We are not trying to forge the crypto tokens in order to forcefully gain some flows or access to the code flow. Yeah, so there are two modes that we cover. One is the normal mode, which establishes the MP join connection and then fuzzes the flow further once the MP join handshake has been done. And one is the mutation mode, which does the mutation on the wire, like flipping a bit on the packet in order to reach the certain code flows that are not available otherwise. So yeah, some part of it is scripted because we have to own the connections, otherwise we won't be able to reach those flows. But there is further fuzzing being done. So we have added multiple mutations on the wire. The join authentication is already there, like I mentioned over here. Like these are the join handshakes which we are able to mutate. But apart from that, we also added a couple more things. Yeah, the DSS and path management tear down, those paths are also, like we added more mutations over there. So we are able to find a few more bugs that stock syscaller cannot. But there is some more work being done over there, and maybe we'll get more data on how much better coverage can we have on data plane as compared to the stock syscaller. So these are the numbers that we got. I used MIB counters as one of the mechanisms to validate our flow, as well as the syscaller dashboard, which shows the coverage and which code paths are being hit. So as you can see, the MP join requests, stock was able to send only 2,300, and ours was like much, much higher than that. And the valid joins, stock was able to do, but again, the numbers were very low. One thing here is that we missed to use the TUN feature in syscaller, which enables it to do packet injection. So we'll be trying that out as well to see if there is any improvement in the stock syscaller's successful handshake. But anyway, I mean, it is still hard for it because it is mainly dependent on randomized fuzzing. It doesn't know that there are certain states which need to be maintained. So we are ensuring that we do that, and we are able to reach the MP join handshake very easily. And looking at the rejection paths, stock is not able to cover any of those, while we can tune this further to even break more, like have more paths, more flows into the rejection paths. So on the dashboard, when we see the code flow on the dashboard, these are there's a code snippet which shows the red blocks are the stock, which it is not able to cover, while we are consistently able to cover the HMAC validation paths. So we were able to find, so we wrote this tool in about 3-4 weeks, mainly the complete pseudo syscall and all the, I don't know Golang, honestly. I don't know anything about Golang. It was completely done by Claude Code. My focus was on being able to find the bugs and reach the code flows which default syscaller is not able to reach. So from my perspective, it was like, I just gave the design of what challenges might be there in MPTCP and similar subsystems. And it was Claude which completely implemented the tool, and I drove the validation. So every single change, layer of change that it made, we verified it against the counter increment or syscaller's code coverage data. So that was our metric to see how well AI is doing to develop the harness. So we found a couple of bugs. We have created the patches, and they are currently in review in the MPTCP list. So yeah, I mean, we are not just trying to bombard with bugs, but we are trying to create fixes and upstream them as well. And we are focusing on the MPTCP branch rather than the upstream branch so that the quality of code would improve before it gets to upstream. Right, so as I mentioned, the harness is completely AI generated. What we drove is the validation around it so that we know that it works as expected. So there were a lot of things where, so this slide is basically, I don't know much about the issues that came because it was just AI who created those issues, who reported the issues, and then I just had a lot of discussions with it and it figured out how to fix these. For me, the metric was whether the coverage is increasing and the counters are getting incremented as expected. So the verification method is the one that we owned, and these were the factors that we checked for MPTCP. And I think, I would like to see this extended to other subsystems as well. So I had a discussion with the Quick guy who presented 2 days ago on the second day. So he too mentioned that this is a challenge for him. He was not able to fuzz beyond the points where handshake is needed. So for that, maybe the matrix would differ, but even that has a lot of counters. So here we used coverage, MIB counters, kernel message to see if something is breaking, and some AI-generated self-test to ensure that each, like for example, if we have an MP join handshake, if it is happening or not, is just a factor of the increment and counter. So those were the things that we validated, and as long as these things are working, I didn't really care what AI was doing in the harness extensions. So yeah, I had to do a lot of prompt engineering. I created a lot of context and made some principles that the cloud code could take in so that it doesn't make redundant mistakes. So like it was a continuous conversation with it, and like we added different contexts for different spectrums of the domain that it would work in. So yeah, it is like the data on this is still small. I ran the fuzzing on stock and the comparison for roughly 3 days, 72 hours or something. But yeah, I would like to spend more time to get more data on how good the coverage is. Okay. Yeah, pretty much done.
So I think the way we're going to work this is because there's a lot of speakers. You can ask one question maybe, and then we can have a more Q&A at the end.
If you don't have any other takers, you mentioned syscaller a lot. Have you looked at k-fuzz test for like heading deeper into the code in the start to start with, to like do more of a unit test style fuzzing?
Sorry. Can you repeat again?
Oh, there's this new framework, I think Google pushing it, k-fuzz test. So it's more inside the kernel of the fuzzing rather than like syscaller from sort of the outside. So I was wondering if you've looked into that.
No, I'll check that out. I haven't checked that out yet.
I really don't know if it's applicable. I was just wondering really because I'm also looking at like, should we be using this? And so just sort of asking for your experience.
No, I haven't checked that out. I did try to search if there are any solutions available which can, pass through such state-aware flows. But I didn't find any, but I'll check out the k-fuzzer you mentioned, right? K-fuzz test.
K-fuzz test.
Yeah, I'll check that out.
So what's your plan on this tool? Is it open source? What?
It is open source.
Okay, and you didn't publish the URL. Maybe we can come back. Okay.
I think.
All right. We may bring you back if. Okay, go ahead. Show it. Next to your Rajat, just.
Yeah,
this
is our GitHub link. You can maybe just check.
Yeah, that's why you need to put like a.
Maybe I'll share.
Yeah. Okay. Or you can post it to the mailing list. Yeah. Okay. Thanks. You may come back after if someone wants to. Okay. Next is Rajat. So if Rajat is setting up, if anybody has another question, we don't want to use this, leave this as an empty silent. Oh, he's going to come. He's not
Yeah, I just have a kind of a extension comment to the previous one about k-fuzz test. I think that could be particularly useful for fuzzing the BPF surface area because you wouldn't have to generate BPF programs and then go through that whole pipeline of validation that they encounter, and rather use k-fuzz test to just specifically fuzz the helpers that one would invoke via the struct-off programs.
All right, take it.
Okay, hello everyone. Finally made it to the last day. Nice job. So I want to talk about the common issue that everyone is facing, which is patching specifically for the AI era. Now, I'm coming from the other side, right? The people who are finding bugs and reporting bugs. So I want to share some of the insights on what things we are using to cut down the AI slop from the genuine results. Maybe some of those things can be useful for the maintainer side as well. to figure out or basically just prioritize the issues which are real, the bugs which are real, the patches which are real, instead of some of the submissions in which you have to spend human time before you figure out if the submission is real or not. A quick who am I? I'm Rajat Gupta. I work in offensive security at Qualcomm. Previously, I've reported multiple local privilege escalation exploits in Windows and recently in Linux as well. I used to play CTFs back in the day, and now I work on AI for vulnerability research, specifically focusing on deterministic verification of AI results and find good bugs. Yes, so same thing. The goal is to basically figure out, let's say you have 100 submissions on the mailing list. How can these submissions verify themselves before any human reviewer time is spent? So this is a basic framework that I propose, which is like 4 verification. Each verification is for each artifact, which is a part of like a submission packet. For example, any bug that you receive, there is usually a POC, sometimes not, especially with the AI reports, it's just the AI output. And then there is a root cause, then there is a patch. So let's see how you can deterministically verify each of these things. First is the trigger. There are multiple levels to this trigger. Basically, the bare minimum is the sanitizer. Like if you say that you have found a use after free, then show me a case and trace. Until and unless you have a case and trigger for that use after free, there is no way that you can determine if that use after free is real or in what conditions though that can actually be triggered. Now, if you say that that use after free is exploitable or is user controllable, then what you need to show me that that use after free case and trace can be triggered from a user namespace. Similarly, obviously we cannot ask for full exploits from each and every submission, but there are things which we can ask, and these things can, I mean, maybe before AI, these were too big of an ask, right? Where people say, oh, this is too much work, maybe for casual contributors. But now I can tell you for sure that this is essentially free. And as soon as you have a use after free, you can prove that that use after free is exploitable or not deterministically with very, very little effort. The main effort goes into finding that use after free. From there onwards, it's mostly documented techniques that AI can already knows or already trained on. Some quick examples. So this is one hypothetical patch. The patch says that there is a use after free in function foo, and then the patch basically increments the ref count so that the early free doesn't trigger, but it doesn't mention in what conditions that can be there. There is no case and trace, there is no reproducer. Until unless you read the subsystem code and figure out yourself, there's no way to figure out if this is AI slop or real. But what I propose, asking for deterministic verification. I will say deterministic so many times, so please bear with me. Because from my experience of finding real privilege escalation exploits using AI, I can tell you that your verification should be deterministic, right? Because AI is non-deterministic by design. No matter how good your models are, how good their training data is, they will always be probabilistic. And if your verification is also probabilistic, then the result will also be probabilistic. In 1 or 2 hits, you will get that golden chunk right, and then you'll see, oh, the world is ending soon. But then 99% of the time, yeah, it's hallucinating. So yeah, same thing. If the bug is real, show me the sanitizer trace, and then similarly, so on and so forth. Also, one thing, sorry if I'm going too fast, I only have so little time. For example, if you want to ask if a bug is exploitable, you don't need to ask the full exploit. They're actually from getting a use after free to going to a full privilege escalation exploit, there are multiple steps that we do, which are intermediate, that can be treated as some sort of a proof. Second thing is root cause analysis. Obviously, AI can generate huge paragraphs of root cause, which sounds just about right. And then you will have functions which look real. It will also mention previous CVEs, which has the same pattern. But then in the end, when you actually spend your time on, you will see that that CVE doesn't exist. So what is a deterministic verification for root cause? Actually, is very hard to deterministically verify. From the research side as well, we are also struggling on how to verify this. But for majority of the bugs that are established, like memory safety bugs, race condition bugs, integer overflow, those you can verify very, very easily. For example, if you want to verify an integer overflow, just use kprob instrumentation, and you will see the exact overflow site where the value wraps around, and the future if checks are being bypassed. It's magic to me. Maybe to you it's not, but we can ask for some of these evidence as a submission packet, so that when human or any reviewer opens that bug, you have hardcore evidence of where the bug is. The bug is real because you have a working trigger. The root cause is also real. So that will save a lot of human time, and then we can just work on the patch. So yeah. Quick example here, same thing. There is a null pointer dereference in foo. The patch fixes it by adding just a null check. But again, who made that pointer null, in what conditions, blah, 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 nothing is there. For example, but if you use something like kprobe, you can see that, oh, the bar is another function which set the pointer to null, but foo still holds a reference, and then later on dereferences that pointer. So, and then the patch actually belongs to bar instead of foo. So this can also show us where to patch as well. Now, verifying the patch. You have a very beautiful patch, maybe more beautiful than any human could ever write. But then how do you verify that that patch is valid and that actually patches the bug which is there in the root cause? People say just like, oh, I think I tested this on my machine, please trust it. But that doesn't work, especially for the scale that we are seeing. So something like this is very, very simple. You already have a POC that triggers that KSAN, right? So please, before patch, trigger that KSAN, apply your patch, and then again run the kernel build, and the same trigger should go away. That is the most basic patch verification that you can have. I'm not saying that this will cover majority of the cases or like every edge case that you see, but this can actually show us, okay, which reports are AI and which need more human time than some of the reports which are valid. So yeah. Then this thing is actually very, very important. I know from our bug finding side, we never do this. We never run tests. We never, ever check that if our patch reintroduces old bugs or introduces more bugs. So doing regression testing should be absolutely mandatory. Even if you are not writing new tests, you should definitely ask for stuff like, please, we can do this on our side as well, but getting this as part of the submission reduces a lot of work. So yes, 3 out of these stages can be a CI job, like literally automated 100% end-to-end from a POC, from patch, from the self-test. Only the root cause evidence thing is not, sometimes it misses things. I'll show you the exact case where it might miss. But these 3 things, these things are optional now, right? Some submission do send all of this, some don't. It's only a matter that we should enforce this thing. So yeah. I hope by doing these things, we can cut down on the AI slop results. At least these things will reveal that a submission is verified or not, and those submissions can be, prioritized where we want to spend human review time. The edge case that I was talking about is the same thing, right? Foo dereferences that pointer, which is null. So the patch stupidly just adds a null check in foo, right? But the actual fix belongs to bar. That function should check, oh, if there are any callbacks which are still waiting for this pointer. That is the original fix. But I think this question is much easier to answer, and we should spend our human time actually on these things rather than spending our time on if this submission is actually valid or not. Thank you. Questions?
Actually, I can take 2 questions. He's ahead of time a little bit.
Sorry, I went too fast, I think.
No, it's good. Can you go back to your previous slide? Anybody with a question for Rajat?
Yes. Any comments?
Maybe I was not able to follow fast enough, but the thing with the Kazan, of course, it's very nice if you get in the report, the Kazan report. That's absolutely helpful, even before AI times.
Right.
But typically, a bug found by AI, by code analysis, won't have a Kazan report. So that is the first question. Well, if AI says, I think there can be a use after free, it will not have a Kazan report. And the second question is, are you sure the Kazan reports are real? If I ask an AI, please give me a Kazan report, won't it just give me something that looks like a Kazan report?
Yeah, so good questions, actually, very good questions. So the Kazan report should be coming from the actual kernel run, not through AI. It's basically like a compiler, right? If you compile a C program and ask AI to compile it using your C compiler, until and unless the code is syntactically correct, compiler will keep throwing that same errors, and AI will have no way to bypass that compiler. Like a calculator, it's very, very simple. Like if you do a math and you have to verify it through a calculator, AI cannot like fool its way through a calculator. So this is similar. These are robust deterministic steps. I mean, the people who are sending bugs, they will have the same results. We will see the same results, and anyone reviewing the patch will have the same results.
Satisfactory answer?
It works. Thanks.
So clearly you're using this to defend on the side against the good, to try and use AI to speed things up, right? I've been of the assumption that AI helps the bad people more than it helps the good people. So although this is a thing that helps improve the inbound side, do you still agree that the bad guys have got more leverage on this, or do you actually think this is helping you get ahead of that curve?
Good. Yeah, another good question. So, I mean, the bad guys, which is me, we are doing the same thing already. We are all, I mean, we don't trust any, AI shows us use after free, like 2,000 use after frees every day. I see that. But maybe 99.9% of them are trash. So these things we are already doing, and I don't see why we should not do the same things on the maintainer side as well. I
fully agree that you should be doing that, right? The question is, does it give you the equivalent scaling thing to take things back to neutral, or do they still have an advantage on the bad side?
No, I think this will give some leverage to the maintainers for sure,
It does, but it does. I'm asking the question
on the bad
about
side.
the relative leverage, right?
Okay.
So the folks on the bad side have gotten a huge lever, right? Are you saying that this lever neutralizes that completely, or it only takes the edge off? Where's your where's your evaluation of the slider on that?
I think this will give even reviewers more edge than the bad actors, because on the bad actor side, this is just an initial filter. On the bad actor side, we are looking for the full exploits, right? Versus on the maintainer side, I am only looking for a case and trace. Which one is simple? So finding a case and trace for every submission is much easier than writing a full chain exploit for each submission. So I think reviewers will have a better edge on this.
Okay. Anybody downstairs with a question?
I keep offering. No takers yet.
So, if I understand correctly, what we need to really automate most of these steps is a reproducer from a possibly untrusted party,
right,
that we need to run.
Right.
And that, I think it's a little bit problematic. I mean,
we can run it in a sandbox.
Yeah, but if it needs internet connectivity, I mean,
I get your point.
It's not. I think it's not completely trivial.
Right.
Do it in a completely safe way.
Yeah, I mean, I think for okay, from your experience of seeing, let's say, last 6 months of security submissions, how many submission had actual exploits? It's hard to think.
I would say 50% roughly.
60%?
50.
I mean, like, they had full exploits, like from root till root, from a bug till root.
No, till root, no.
Right. Yeah. So
something that you run in CS plot.
Correct. Yes. So that, I mean, it's not very easy to convert a use after free to a full chain exploit. And if we do it, that the value is tremendous. The value of that exploit is very, very high. And if someone has a full chain exploit, most likely he will not submit to the Linux kernel directly. He will find a third party to get the money for the exploit. The most of the bugs that people give to Linux kernel, they are worthless to them. I mean, there is no monetary value that can be extracted from those exploits, or they have already tried submitting somewhere elsewhere and they have rejected those submissions. Until and unless that submission is dead, then only people submit here. But with AI, now anyone can find those exploits. So we can also, I think, improve on that. I don't know if that answers your question. I know it's hard to run on the maintainer side, like automatize running untrusted code. That, I think that is a different question. But what I wanted to say is, like, instead of spending human time on each and every mailing list submission, that is, I don't think that will scale, and that will burn out majority of the people very, very soon, because we don't know, this is the new normal and we don't know how long will it last.
Yeah. By the way, the numbers that you gave at the beginning of the slides are actually a very large underestimate of the delta. I think there is at least one order more of magnitude from before to now.
Oh, okay. This one. Okay.
Sorry, we're going to kick out Rajat off there. He can come back after.
Thank you.
Downstairs, you'll get the first priority on the next question.
Hi, everyone. I'm Yuan Tan from University of California, and I just recently founded my company, Nebula Security. Today, I'm going to show you how my team finds bugs in the Linux kernel and how we cut down the false positive to 0. Rajat's talk have a lot in common with mine, but I hope I can still share something more to you guys. This is my team. We are the folks that whose patches have full reported bad tag. That's not good. And in the future, as our agent finally has a name right now, so we will switch to the agent. We'll switch to the reporting under the tool's name instead of our name. Okay. So if you may heard of us in the security world. We landed a remote code execution on an Android device that can root your phone via a simple URL. Since March, Vega has found more than 600 valid bugs with the POC in the Linux kernel. And I actually just hit the bill. We spent around more than $100,000 in token to do this. And we are not only reporting them. Actually, we are trying to, every bug report has a human prepared patch to fix the bug. And we have fixed and upstreamed more than 100 patches, and most of them are being merged. And 86 of them are in the data system. And we found that over 10 of these can be exploited for you to get a root. They were simply too many bugs to fix, so we couldn't dump all of them to the mailing list and to hope someone else can fix them. So actually, we put together a lot of volunteers from all around the world to help. Most of them are undergraduate students. They never submit a patch before, but they have passion, they have time. So what we do is I teach them how to fix the bug, how to write a patch. Then we have a guy to review them patch before sending out. You may say your mail list is full of patch sent by Renwei. Actually, that's a guy who review their patch and send it out together. We have more than 20 volunteers. That's a lot, and that's how we got 100 plus patch get merged into a kernel. And also, thanks for every maintainer and every reviewer to review our patch. Really, thank you. Okay, about Vega. Vega is designed to work on large-scale code base while minimize the risk of missing bugs. But the one single advantage of our tool is that the bug reported by Vega, there's no false positive, no hallucination. They are all valid bugs. It comes down to 3 questions. Okay. So, as we, I want to walk through why bug fighting with LLM is pretty hard. Instead, it's not that simple. It's not that simple as you telling an agent to say, go find a bug. It's not that way. There are a lot of reasons that LLM find the bugs report turns out to be a false positive, and some turns out to be trash. So I'm going to break them down one by one. Agent will happily to tell you they found a lot of bugs, but some of them, most of them, cannot be reached at all. Because the agent may find a piece of code that looks buggy, and locally its reasoning may be correct. But the problem is the agent doesn't always understand the full path to reach the code. The path may be already being blocked by some earlier check, or the code might never run in a real system. So even the report sounds convincing, but no one can have a POC to trigger it. So the key question isn't just is this code buggy? Instead, it's can running kernel actually reach this code and trigger the bug? So this here is our solution. It's kind of similar to Rajit. So we don't trust the output of the model. We trust the crash log. We run kernel with sanitizer turned on inside QML, and we ask the agent to try to trigger the bug and crash the kernel. So if there is no crash, no crash means the bug doesn't exist. But you may ask, what if agent fails to reproduce a bug that actually is real? Maybe we will miss it. Let me show you the data. So half a year ago, the honest answer was yes. The agent might fail to reproduce a bug, reproduce a real bug. But now, with a much stronger model and some hardness, the number jumps. So you can say in Vega, we can already produce more than 95% of the bug, of the real bug. So the agent is very clever and trying to trigger a bug, but it still needs some constraints. For example, we forbid it from loading a kernel module. That's cheating. You know, with the kernel module, you can almost trigger any bug. So we forbid that. But however, there's some bugs there are some special bugs that actually cannot crash the kernel. For example, the famous Copperfield bug. It doesn't have any memory corruption, so actually KSM won't work. So in this case, it's not performing that well, but this kind of bug is really a small set. So maybe we can just ignore them. So here's the takeaway. So whether the agent produce a POC can tell us whether the bug is real. I think it's quite useful because with this, we can no longer have to spend time figuring out whether this bug is real or not. Yeah, I have been thinking about maybe this stuff can be integrated into Sashiko's finding because I have found some Sashiko's finding is not real. So maybe if we can integrate this stuff to Sashiko and trying to reduce the false positive, that will actually helps. And will help a lot of time, actually. However, a crash cannot tell you if this bug is a security bug. So we have a second challenge. The second challenge is a third model. Greg has already mentioned this before, because the agent doesn't know what kind of bug is a security bug or a normal bug. Our team once made a very embarrassing mistake. We reported a bug to the security team, which triggers needs changing the kernel boot parameters. But if you can already modify the boot parameters, you can already control the full system. So that's insane, I think. So that's a pretty embarrassing experience. We have since improved our process, and now we handle this case much better. So now we have a true bug list, but it's still too many. Which one is worth fixing, and which one which one is dangerous enough to fix them immediately, and which one we can wait and ignore maybe for a while. So actually, when we produce a bug, we ask the agent to find out the minimum privilege to trigger the bug. It will get a root POC first, and it will try to trigger it while namespace, while privileged users, level by level. If a bug can still trigger by a normal user, it's very dangerous. We also graded the bug while the primitive, as Rajit also mentioned before. Yeah. And even with all of this, sometimes it's not enough. Here's an example. Here's the one bug we found. This bug only triggered when the clock is 1917. But it's a data mass breach, and there's a bad shape crash the kernel. Is it a real bug? Yes, it crashed. But is it a real problem? Almost never, because we are not living in the 1917. So this is a gray area. The tool can tell you it crashed, but it cannot tell you it's worth fixing or not. So we will still keep human in the loop to figure out this kind of case. So far, I'm talking about how do we find the bug and fix the bug, and I can also share how we propose a fix using AI. So we are experimenting some new stuff. Okay, POC doesn't just help verify bugs; it can also help to fix them. So if the same POC that proves the bug is real can also prove the fix works, right? The agent can propose a draft patch, and the draft patch only pass when the crash no longer triggered. However, the draft patch usually doesn't clean enough to merge into kernel, so it still requires a lot of human work to do this. But it may help us to propose a better version of patch. It's just a draft. So if there's one thing to take away is we have to verify the AI's output using some real real evidence, for example, some crash. So imagine, and the model getting better, and we have two systems terminating parts from both sides. Sashiko will get the new code from the beginning. The new commits will stop adding bugs. And our Vega will find bugs and fix the bugs already exist in the kernel. So the new code stays clean, old code gets clean until there's one day maybe there's no bugs in the kernel. Just imagine, maybe. Now I'm trying to build a dashboard to connecting all the bugs finding by AI. Not only Vega, but also Sashiko, also other report in the mailing list. So the maintainer can review the list and trying to maybe can say is there any bugs already fixed or which ones already reported or not. And we are also trying to produce a POC for bugs that are reported by Sashiko. I believe this will save us some time and some efforts. I can maybe show you the. Here's the demo of the info of the dashboard I'm building. We can say we can say the POC. We can say a crash log. Yeah, in the future there will be a agent proposed patch for reference. Yeah, if anyone want to join us to fix the kernel to make the kernel better, please let me know. We can do it together because you don't need to fight bug. You don't need to burn your token. We already burned that token. We already burned 100,000. So you can just join us and fix the bug. Thanks.
Thank you.
Questions? Yeah, okay. So you, the dream of having a bug-free kernel, nice idea, right? It's probably going to follow an S-curve where we're probably at the knee up at the bottom and we're not anywhere near the point of inflection and the roll-off at the end. Have you got any sense of how far you think we're up the beginning of the process at the moment? Or
actually, I have one experiment with whether the agent can replace the father. I have one experiment, and it shows that the agent can already find 70% of the bugs that are found by father. So the agent is still not strong enough, but I believe maybe tomorrow AGI is coming. I don't know, but the model will be better, and we will have better bug finding tool, and we are patching them faster. And I think maybe we are already on the road to that.
I agree with all those statements. That doesn't set a timeline. That's monotonically increasingly better, but there's no timeline in there. Do you have any sense of a timeline? Think this year, 5 years, 50 years? Will I be still alive?
I don't know, but I think we already fixed the most dangerous bugs already. Yeah.
Okay, bold statement.
Hey, Yuan. I have one question. So how do you verify the primitives that the model says? Like if you have a use after free, and then the model says, okay, this you can convert it into arbitrary read and write. Do you ask it to write a POC for those primitives, or you just trust the AI analysis?
We just trust the AI analysis. but in most of the time, it works.
Okay, so the bugs that it says, okay, this can be converted into arbitrary read, right?
Yes.
Okay, without POC.
Yeah, we don't have any others harness. We just ask AI.
Okay, and for let's say for every hit that the model gets, do you ask it to write a POC for every hit, or how do you reduce the false positives?
What do you mean every hit? You mean every finding?
Yeah, every finding.
Yeah. Ask it for every finding we found.
Okay, without POC, no finding goes further.
Yeah,
right?
without POC, we seen this bug as the false positive.
Great, thanks.
So you mentioned Sashiko. Here. So you mentioned Sashiko, but I think there's a question of scale there, right? Because the mailing list is an infinite amount of things to look at, and the kernel itself is finite. I mean, it's big, but it's still finite. So do you think it will scale to that extent that you can really try to get a finding for everything that something like Sashiko flags in a new patch? Because by the time you're done with that, you've got 100 new patches waiting. So I feel that scale is difficult. So what do you think about that?
And the first Vega is designed for scale, actually. So actually, a lot of bugs found by Sashiko is also found by us. We can actually do a simple search to say, if this bug already being reported. If yes, we can say, if we have POC already. If not, we can just say, okay, this is a false negative, false positive. You're right.
Before someone upstairs, can we give a chance to the people downstairs?
I've been waving the microphone around,
okay,
and no one is taking it.
All right, good. We have a lot here, but 2 more questions, and then we have to let the next speaker. Okay?
Hey, I have a question based on what Rajat said. What was the ratio of false positive versus the legitimate bugs that you found?
Pardon?
What was the ratio of the false positives?
Okay, we have actually Vega found more than 2,000 bugs in the kernel. There's only 600 is real. Okay. Yeah. Maybe 3,000, I don't know.
Hey, here. I have a question about whether you have any ideas how you can solve the problem of race conditions when creating these POCs, which is a similar problem to what we have in syscaller.
Yeah, actually, the agent can use K-pop or something like this to trying to make some race condition worse. Yeah, we have some race condition bug. The agents will write a POC that running maybe 1,000 times, trying to prove itself is true.
Okay, so the agent hypothesizes if there is a race condition and then tries to come up with some way to trigger it. Okay.
Yeah, actually, it will try any means to make it work.
Okay, awesome.
Quick one.
I wanted to say or ask similar questions. So you could maybe allow or add to the kernel just function to slow down certain functions to your model.
Pardon?
Have you considered slowing down some functions to inject a timing issue?
You mean you inject timing for some race condition bug? Yeah, we haven't do that.
And also for memory failures injection.
Yeah, we think about this, but we haven't do that right now. So maybe we can improve that. Yeah, because we forbids the agent to rebuild the kernel. Otherwise, it will cheat.
Okay, although I said last question, because I have dictator power, I can ask one more question, right? Do you have agents? How is this thing implemented?
Pardon?
You have an agent system that go. Are you able to describe your secret sauce? Do you have agents? What are you doing with? How are you doing all this stuff?
Just find you are an agent. You are an expert in security. Just find some UAF bug. That's simple. It's very simple
but
problem.
use your own infrastructure, right?
Yeah.
Okay.
Very simple problem.
Stefano ready? Stefano, if Stefano's not ready, okay, we'll allow one more question maybe.
I just have a comment to what you said.
Yeah.
Is it a bug or a code? Try crashing the kernel. It's that simple. That's what he said.
Yeah. Okay, thank you. We may bring you back after, depending on how much time we have. Okay, so next is Stefano, and he's going to look at this from... I'll let Stefano speak. Well, you're still connecting your laptop. Maybe I'll do a little intro. So he's going to look at it from a developer perspective. These guys are reporting bugs. They're setting very bad bug fixes. And then the developer has to look at it because it looks legit. Okay? That's the point of view we're going to get here.
Okay, so Thanks, Jamal. Sorry, I just arrived biking from the opposite part of Rome, so I missed the first part of this presentation. So I hope that I will not say anything against what was already said, but I mean, in any case, it will be useful to discuss. So I'm looking from this perspective. I mean, the cost asymmetry of AI-generated code, basically the comparison between how it can be easy to generate code versus the difficulty to review the code that is generated. And so this can put a lot of burden, for example, onto the maintainers that needs to check this potential AI-generated code. Disclaimer, of course, we are not here to blame anyone. It's just a case study to learn from, and also, especially because there are really no already agreed best practice or rules, let's say. So in this case, I think that everybody is now experimenting what we can do with AI. So it's not the purpose of this presentation to blame anyone. So I do believe AI is very useful. So this is not a case against AI. It's just in the spirit of learning, I'm trying to discuss how best we can use it. Okay, and I'm not the maintainer of any part of the kernel. Basically, here I'm just observing something from kind of external point of view. So I'm just observing a patch that has been submitted and a review that has been made by the maintainer. The only disclaimer that I work closely with the maintainer, so I can get some feedback. But basically, everything is done from an external point of view. It's not the opinion of the maintainer. So it's not something specific to the patch. It's just, I repeat, try to put on a high-level perspective. So there was one patch set that arrived. Actually, it's seven different patches, and it's around 5,000 lines of code. Okay, so in one day, from version 1 to version 2, all findings were addressed. So it appeared as a potential good patch to be reviewed. So what I meant, every chip quality signal looked good, but of course none of them measured the correctness, the real correctness about this. Okay, and the patch included the 2,000 lines of self-tests, and of course the self-tests were passing. Everything was fine, of course. So we basically, I mean, this is of course our rough estimation. I mean, that you can take one day to generate such a patch, and then I really had a look. Pronto? Sorry. So, and I had experienced that the review took 1 month, and then it took 8 emails, 40 different findings over this patch set, covering only 5 of the 7 patches. So after 5 patches, it stopped the reviewing, not covering the 2. And of course, the outcome was just a start over. So basically, the initial patch did not contribute a lot. And if we want to actually go on, also the maintainer has some additional tasks, because in order to try to fix, then maybe other preparation patch needs to be done. So we believe that this is a 5 to 10 generation to review cost. So the generation is 10 times easier than a review, in our opinion. This is what we measured out of this trend. So this was the 40 review findings over the first five patches. So there were something really, I would say, wrong in terms of conformance to the specification. I mean, the patch was the intent of the patch was to implement an IETF RFC about mobile SRv6 plane, but going into the details, the implementation was really not conformant to the RFC. Then there were some problems, for example, in malformed SRH that were accepted, HMAC that is checking the segment list was bypassed. A very critical thing is how the design of the user API, so the IP root, let's say, part, basically it really reassigned the semantic in a kind of random way to existing attributes. So you have some attributes to give commands, and the patch choose some attributes and give a new semantic meaning in the context of the new requirement. So of course this syntactically works, but it was clearly a semantic nightmare, basically. Yeah. Then there were very, very strange things. I don't know if there is this very. This is for example, a very, very peculiar thing, because it took 1 week to the maintainer to understand what was the problem. So basically, when you rewrite, of course, IPv6 address, basically you have to recalculate some checksum, and basically the system did not calculate the checksum, but the self-test passed because specifically crafted IPv6 address were added so that replacing them made the checksum okay, even if, of course, if you just change 1 bit in the IPv6 in one of these IPv6 address, the checksum does not check anymore. So clearly that was an artifact of the generation of the code that trying to fulfill, let's say, to pass the test, was crafting IPv6 address, especially to let the test pass. So this is clearly something that a human mind will never have arrived to such idea, no? So, I mean, that was 1 week, because it's something that you will never think about to look for a thing like this. You think that for some reason the checksum was not triggered by other reasons. In the end, that was the reason, no? And so there are let's say a lot of things that are plausible but wrong, basically. So the takeaway here is that some surface signals of quality are decoupled for correctness, and instead the semantic aspect for checking the code against the intent, so what really you want to do, is mostly and still human work. It's also interesting, in this case, I would say that AI review were not good. So I do believe that, I think this is maybe a step in a process. So I really think that AI review is good, but in this case, it proved not. So basically, the AI, in a few hours, and we estimated $34 in tokens for do this. That was our rough estimation. So basically, did not check, of course, any of the real semantic problem of this, so that the implementation was not conformant to the specification, or that, of course, the user API semantic was completely overridden. Of course, none of these were catched by the AI. out of the 40 findings that the maintainer was able to catch, 9 of them were actually reproduced by the AI. Then you see that there are 31 unique findings by the human and 5 unique findings by the AI. Of these 5 unique findings by the AI, so this is, let's say, which is the contribution. In this case, 2 were real catches, but I will say very, very minor, not really blocker. And in addition, unfortunately, 3 false positive. So also this added kind of a burden to the maintainer because we had to, because the maintainer had to understand the false positive and reject, let's say, this indication. Okay, and in particular, these false positive were basically based on some weird invented kernel mechanism. So he found that the system was not, the code was not good against some mechanism that was not actually existing in the real for that specific And in particular, the one that the AI review flagged as critical was one of these, let's say, self-invented. So in this case, but I repeat, I do believe that this is a matter of maturity of the AI review tool. In this case, the AI review actually exacerbated the problem of the burden on the reviewer rather than releasing it. So this is what I try to put on the discussion. First, I do believe that we should disclose AI use just as an honesty norm. It is completely orthogonal to acceptance. I don't think that there is a problem in submitting AI-generated code if it is good code. The problem for me is, in general, submitting bad code. So that we shouldn't focus on it is AI-generated or not. Is it good or not? And of course, there are some things that are really difficult to check for an AI system, like the problem with the semantic of parameters, and of course the fact that when you do change on these semantic of parameters, you really create a problem forever, because of course you tend not to change it for backward compatibility reasons. Then, of course, a human needs to keep the merge decision. And here, I repeat that the takeaway is the scarce resources is the expert maintainer attention, which we should try to safeguard it. And how can we safeguard it? So, of course, improve AI review, and we do believe that we can understand what was wrong with the AI review. So, for example, I do believe that each maintainer could try to customize the AI review system with a set of specific prompts of things that he knows that should be checked. So this can help improving this. And also try to start a feedback loop. So we should feed into the AI review system some feedback on what was really wrong with the review, hoping that then this will improve. And I think there is this is how typically AI system evolve and improve. And then I do think this is, the most provocative part. We should, in some case, do a kind of desk rejection. So when we see that the code is so, I would say that the quality overall of the code is not good, we should avoid wasting maintainer resources. So now the problem is how we do, of course, this. In general, I don't think that we need to do it because it is AI generated, but because it is badly written. So in the submitted patch, there were a lot of patterns that a human being will never have written, because then they are very difficult to understand and to maintain. So these are signals, actually, that there is no good, it's not a good code, okay? So when you start adding some custom, some cast here and where to make, of course, a different function accept the parameters, but they have no logical reason to do this cast from one type to another. I mean, you can start understanding that something that a human will not do. And so we'll see that we should have something that when we have some gates that are not reached, we reject it. Another sign was, for example, the quantity of replicated code. There were some 5 or 6 portions of code that were just replicated by here and there in these 5,000 lines of code. And this is also a typical pattern that a normal programmer hates to replicate code here and there. So this is another sign. Now, of course, the discussion is who defined this, the bar. Continuous integration, patchwork, the maintainer itself, I don't know. I mean, I'm just starting to put this to the discussion. And that's all. Thank you for your attention.
Hey, Stefano. Yes, good point on the semantic side. What do you recommend? How should we verify the AI output for semantics?
I think that the only possibility is, in this case, some maintainer-owned prompts. So I think that, of course, extracting the semantic from some modules or some subsystem of the code is something that currently a maintainer can do. Mm-hmm. And so we can just put some rules, for example, about the overriding of existing attributes in the UAPI. I think this is something that at least you should trigger an alarm. Is a patch is using an attribute? Is it using in a correct way? Is it using in a new way? Mm-hmm. And
doing this for the entire subsystems on the Linux kernel would be huge.
I would say that ideally, I mean, each subsystem should start defining a set of invariants or a set of things that it wants to be checked on a semantic level when such patches are submitted. I think this could be a proposal, but of course, this is just
Thanks.
It requires, of course, the effort. So the effort that I want to save from the maintainers, of course, in this case, it required to start building these safeguards, let's say. Yeah.
Okay, I want to comment on that. I think that the human submitter should be the first person to verify the semantics. Otherwise, it's like totally broken, the process. And if someone does like the wrong thing multiple times, it will be like maybe not excommunicated, but like mostly ignored. Yeah. Thank you.
This is
great talk.
Of course, a good point. This is, I mean, it could be a part of what we call desk rejection, so that you, in a polite way, we can. I think that. I mean, this is a little bit different because, I mean, 10 years ago, if you receive 5,000 lines of code, you always think that someone has put at least some effort in doing this. And so the typical approach maybe is of the maintainer, okay, let's look what he has done. In this case, maybe we can, let's say, have a lower bar for getting back, for giving back the patch and say, please, drastically revise it before trying to resubmit. I think that could be the...
For sure. We'll give some people downstairs so they don't feel left out. Anybody have a question down there?
No, still no questions.
Okay. It must be really nice down there. Temperature's good? Okay. Oh, yeah. Look at them. All right. Okay, I'll let you ask. Can I just crack a joke? What $34 to...
Sorry?
You paid $34, I think, yes.
I think that we do not pay. I think we estimate roughly the number of tokens that AI review would have taken, and that's the estimate, I think.
Sorry, and what's the destiny of this PR from the first slide?
First slide?
Yeah, I mean, what happened to it, like, in the end?
This slide, you want to?
No, your first example with 5,000 of lines of code. Yeah, this one.
This one.
So, what happened to it? Like, did you merge it?
I think currently there is a version 2, an RFC version 2 that the maintainer has not yet started to review. So, but after our set of 40 comments, this is another sign that all 40 comments we received the yes, okay, yes, okay. So all the comments that were given to the submitter, they were accepted, and now the submitter is trying to resubmit a new version. That's the current state.
Anjali, you're holding the mic. You're the speaker on that. Okay, so our next speaker is not available, so we could make this a free form, including the previous speakers. Okay.
We don't hear?
All right.
Okay. Do we do any form of attestation, like when people are submitting bugs? Do we actually verify that they are people and that we can relocate them?
I don't know that if it is a common procedure, but in this case, I know that this is a people. That was not a bot. In this specific case, yes.
You talked about the property. So we're living at the moment in this time where the original belief about open source was all bugs would be shallow and people would find them. The reality is that humans are lazy. They like to just push buttons and say they looked at something. And so we're all fallible. We didn't do as much reviewing as we all thought we were going to go do, and there's a bunch of landmines out there for the last 40 years, which is perfectly okay as far as I'm concerned.
Definitely.
The AIs happen to be a lot more diligent. They're also hallucinatory, and they do a whole bunch of other types of things. But if we have the resources, we can throw them at these things for a lot longer.
Absolutely.
So we're really dealing with this change in model of things where we need to be hyper diligent about stuff because the bad guys can be hyper diligent about stuff, and if they find one vulnerability, they can exploit the hell out of it.
Yeah.
But we're dealing with this mixed model where humans, they're not going to work any extra hours. They're already overworked anyway. It takes that amount of time for humans to go through the process, and they've got their own pipelines, and you're not really going to fix that. And then simultaneously, you're trying to inject these AIs into the system, which at the moment, last year they were terrible. This year they're sort of maybe whatever it is. At some point, they may become omnipotent, and then we can just all go and retire. But you're talking about a very interesting problem in time. So how do we deal with that, right? Because yeah, well,
without doing anything,
moratorium, right? That would be a good idea. Wait for 2 years might be the right answer, right?
No. 2 years is too long. So what you do is, AI is good at pattern matching. You are good at joining the dots. So you do your part, it'll do its part.
Okay, so we have to pay these people who are not getting paid enough anyway to fix all this stuff. Who's paying that? Who's making sure they don't burn out?
Yeah,
okay.
Yeah. I think. Yeah.
So you mentioned that the submitter replied to every change request with yes, and that is kind of expected for a newcomer. I mean, when someone is a newbie in the project, you usually, well, Maintainers are very intimidating, and yes, yes, yes. But the problem that I see here is that if they are not doing their work themselves, they are not going to reach a point where they are able to challenge the comments because the learning pipeline is broken. They are just hitting enter, 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 enter.
Yeah.
And therefore saying yes, 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 yes. Yeah. And at some point, I don't know who is the maintainer, but that maintainer is going to retire. Who is going to be the next maintainer? Because the young guy...
Yes.
Yeah, right.
The models will be much better by then, so we don't need maintainers.
I don't think that was a problem. I mean that was a genuinely good intent that there is an RFC. I mean, this RFC needs to be implemented sooner or later. They wanted to do, and they try to do the best using the tools. So it's a new things, and so that's the point. That the tools are started to get used, but now we should, in this case, make some rules that. My opinion is that it's even faster for the maintainer to implement the specification than to review this code generated in that way. So we should, I think that the only point is that at the current time, there can be a really inefficient way if we do not stop this type of submissions.
Okay, I'm going to change the format a little bit since we're waiting for Roman. The Sashiko guy is not, it's 4 a.m. where he is. Do you want to, all the speakers maybe can go up there and, you want to go up there? All of them, and then we can do like
panel,
you stay there, yeah,
okay.
And everybody else.
Can I make a comment?
Yeah.
If you ever take out the human out of the loop, the tool is no good for human.
Yeah. So I'll give the mics, and then we'll just have one mic floating around for questions and free form. You can rap, you can do whatever, you can dance.
We do have one down here.
Oh, there's a question downstairs, finally.
Yeah, so one of the things I'm wondering about with some of this is if we couldn't start pushing back on some of these patches. They're coming in, they're like 1,000 lines per patch, and start looking at, especially for these AI ones, trying to force them to break things up more just so it's more easily read by humans. Because that's the thing, is for an AI, it's sucking down 1,000-line patch and just, oh yeah, this all makes sense, it's all laid out correctly. You know, it does what it's supposed to do, it's pretty quick. But for a human, we don't really have the mental context to hold, you know, a 17-patch set that's 1,000 lines per each one in our heads. And so I really wonder for these if we shouldn't be pushing back to, like, you know, maybe 100 to 200 line limit ideally for a lot of these big AI sets, just so it becomes something that's easier for the mental model, for us to digest mentally when we're having to go through and review them.
What if AI sends 100 patches of 100 lines each?
Well, then the AI is doing things wrong. So that's the thing. It's much easier for us to...
It passes your criteria of 100-line patch limit.
Well, that's the thing, though. So historically speaking, like if we push a new driver, we don't push the entire functionality all at once. We don't push a 10,000 usually like line patch all in one patch, and we, you know, even to then we have limits on the number of patches we usually send. So like for example with FBNIC, when we pushed it initially, all we pushed was the basic L2 transmit receive. The rest all had to come later, and so it becomes breaking things up into incremental pieces then at that point. And so that's what you'd have to force on the AI model. It's like, okay, this needs to be digestible. You can't send thousands upon thousands of lines for the human to have to try to review over a month's time. It needs to be something that can be reasonably broken up to where it's like a single person can review in like 1 or 2 hours, not 1 or 2 months.
Okay, I'm sorry, Roman is now here. So I'm going to we'll come back after this, right? Unless you have a quick response, Yuan, or?
I just have a response for Alex. 6 to 7 lines in one patch and 6 to 7 patch in a series. Cut it off. Comments are free.
Yeah, he says, so Maciek was asking if the 6 lines include the headers. Sorry. Okay, so we'll bring Roman in. He's not ready? Okay, let's just continue then. Okay. Yuan, you have something to say?
Yeah, I have to mention about how do we find this 600 bytes. Actually, we are scanning every file. So that's how we burn our token. Every file, sometimes we will split some files into smaller parts to make the model have some focus. Sometimes we'll merge some files together to see if there's some relevant error. May require some two functions together, so we can find the bug, something like that.
I have a general question for all of you guys. Do you think, actually you and Rayat probably, and maybe you, do you think at some point can we get rid of maintainers as well with these subsystems? Do we need them, or do we need less maintainers, or what's your view?
So in my experience, one thing that AI models lack is context. They don't know what we are doing and why we are doing. So, I mean, from that perspective, we do need humans to tell what we need from them, right?
But that's today. I mean, the models are still not the best. Okay, Alex wants to say something. Go ahead.
Well, I was going to say, in terms of using the AI to find bugs, one of the things I've found useful is actually having the AI put together a proof of concept in proving the bug. So, like, especially for the drivers, like one of my go-tos is I have a dual QMU model set up with packet generators on both ends that it can control. And then it's just like, okay, go ahead and search for the bugs and put together a test case that proves that this is a bug. And if you can prove it, then we're going to go ahead and fix it. And so that's one thing we could look at for a lot of this in terms of, especially with QMU models, usually they're pretty cheap to set up. And we've got a lot of devices out there like FBNIC, for instance, that's already in QMU. So it becomes something where if we want to try to prove something is a bug, it'd be very easy for us to put together a quick test in something like a QMU environment to go ahead and force it through.
Yeah, I think that's kind of enforced now. You know, they always have to produce a POC. Sometimes it's a C file, sometimes it's a script. That's enforced today. Have you submitted? You have to put a test case in your bug report, right?
Yeah.
A
Yes.
reproducible.
So to your point, Jamal, like when AI gets better at the semantic thing, like connecting the dots, basically. So when AI gets better at understanding semantics better than the maintainers, I think at that point we can see what the actual effects are. Currently, it's just syntactic search, but getting verified semantics is far away.
When do you think that time is coming?
I mean, if I know, I'll be a millionaire, maybe.
Okay.
Yeah, for me also, I have a question about the POCs, because we said that it's good to have POCs to reproduce bugs, but what do we do with them? I mean, usually when I get POCs generated by AI, it's something really huge. I mean, sometimes I don't even try to understand it. But also, I would like to have something that would cover this specific use case, not to have the issue later. But I cannot integrate that in the self-test. So if the POCs could be integrated, something that exists, like only adding a small bunch of code would be good. Like if you can generate packet drill, for example, and integrate that in the test suite, that would be great. Otherwise, we have a bunch of POCs, and maybe the bugs would happen again later. And
yeah, actually, we're trying to minimize the POCs, but sometimes the POC is that big, we cannot minimize anymore. And a lot of bug control cases, we have submitted some self-test to the mail list, and sometimes maintainer said, "Oh, we don't need this. We just get rid of it." So then we didn't submit a self-test anymore. But I don't know how maintainers feels about the self-test, but I think for some of them we still need it. But some of the bugs reported by AI, we still don't need that. That's just some very extreme control case. It's just, yeah.
So I want to come back a little bit to the semantic idea. So I really think that already now, with the help of the AI, you can extract some semantic models of a single subsystem of things like this. I mean, and then you can really have this one to check also not only the syntax. Of course, there is the system that now they are proposing, they are very generalist. Of course, they start looking syntactic aspects and common patterns that are, of course, common to C code or even to kernel mechanism. But of course, I think that current models, if we ask them to extract semantic from subsystems, they are good at doing this. And then on top of this, you can really create some systems. So I think that that's a really an interesting direction that every maintainer could start thinking. Yeah.
Hello. Yeah. To your point, actually, so this is my current research on automatically, like deterministically verify the semantics of AI output. But like you said, right, until and unless we verify that the semantics extracted by the AI are correct, without human verifying those.
I think that at the current time, you need the cooperation of a human and of the AI. And so based on this, you can build some model, some skill. I mean, if you talk in anthropic way, you can build the skills for doing something by cooperating with your generalistic model, and then you easily, 1 week of work, you can really do a huge semantic model of a subsystem. Yeah.
Yeah, so I do have a comment, though, still. I mean, I agree with those things, but without having, getting back to the context of what a subsystem actually can do or what its intent is, your model, I think you're going to have some kind of generational leap again from where we are to have that kind of intuition. You're always going to have someone then, before that intuition is built into the models, you're going to have someone verify what exactly is the intent, and that is the maintainer. It's someone who has the experience, someone who understands how all of the pieces fit together, and maybe the models make them way more effective to say, okay, did this crap code that I just got, is it okay? Or help me generate something that I know how to do, but it would take me a week of work, I can get it done in an hour. But until you have that leap, I don't see how the human maintainer is replaced. I feel like they are armed better to spend their time better elsewhere.
Anybody?
Maybe one question if we have time for one more.
Oh yeah. We were waiting for Roman to join.
Okay.
So if he doesn't join, we have plenty of time.
Okay.
Yep.
For Stefano, there was
there's a comment online? Okay, let's give the online guy. They're deprived of opportunities to speak. So. Okay, do you want to put it on the screen? Yes. Okay. We don't see anything. Okay. Okay. Who wants to respond to that, or? Oh, okay. So is this a comment or a question? Okay. Okay. We're using code review as a gate for merging because it was cost-effective method. Verify patch status out of 10. The method will disappear eventually as the code generation is way faster than code review.
So either this means that the code review will be overwhelmed by this code generation, but if you use it as a gate, it's a problem of the code generation. Or another way to see it is that, of course, we can directly generate good code if we give good prompts to the code generation. So this is another way to see it. That maybe if you are doing if we are building skills that are helping the AI to generate good code, maybe we will not need so much review. This is another dream. Let's say that currently, as we have experienced, giving, for example, an RFC to an AI generation system does produce what we see, 40 bugs in 5,000 lines of code. So maybe in the future this will become better.
I'm going to just say that no human review, no merge. I mean, the code is going to be crap if you take the human out of the system.
Yeah, hear me? Okay. Yeah, the online questions just touched what I wanted to ask. So the cost problem, if it's, even in theory, in principle, it can be how much more it costs to verify for the same model if a patch generated with one model and the same model verify it, for a human it makes more time to create a patch and or the same ballpark than generate and for review. But for AI, I don't know. I feel like is always be more money to review a patch with the same confidence, or it was as said, we have to wait a year or 2 years to have the same confidence for the same price too. So I don't know if it's because your estimation from $30, it was I guess it was a very, very minimum, let's say.
So one of the things that I'm finding in common over here is that we are trying to contend patch quality versus the speed of patch generation. So I mean, something that I have done in my the way I'm using prompts is based on the Linux kernel documentation, where we had added recently that you can use the assisted by AI tag, but you should be able to stand behind your own patches at the end. You should be able to defend them. So the way I'm using context into my Claude code is that it does not generate the final patch for me ever. It does not give me the end answers, but it excavates the code for me. And wherever I'll be taking more time, wherever human would take more time, it does that for me, but I have to come up with the final answer. So it's sort of like maintaining the balance between patch quality and the speed. So, yeah.
Let's have someone downstairs if they have questions.
Yeah, so one thing I was just kind of wondering about is if we're going to basically, so essentially what we're talking about is needing to feed more metadata into the AI agents that are doing the review. I'm just wondering if we're going to do things like maybe look at having the AI agents scan the entire mailing list for the last N number of years and put that into a metadata context for it to use. Because I'm assuming somebody must have done something like that at Meta at some point, because I know I've had one of my agents go to work on an QSFP project that I was putting into sfp.c, that all of a sudden it went and informed me, Russell King's not going to agree with this because, and it started quoting this chunk of message from, I'm guessing, some previous patch set. And so I'm wondering if we should be looking at doing something like that in order to help take some of the workload off, where since it is a pattern matching tool, essentially just feed it the entire mailing list, and then when it sees a patch that looks like something that's been rejected in the past, it could just grab it and go, okay, be warned, so-and-so didn't like this, so you're likely to get X response.
Yeah, exactly. It is kind of dangerous because on the mailing list there are a lot of patches that were not finally merged. So we would need to probably filter them out by the ones that were merged to get the correct answer, or at least correct error answers.
Well, right, but still, if it's been rejected before, or something like it was rejected before, it becomes a data point that you can point to then and say, okay, these are the possible warning points. Because if nothing else, it'd be nice to have like when I use an agent, normally I'm using it to do a first pass of, okay, do a sanity check to see if I'm even going to bother to take a look at it before I go ahead and invest my time to look at it. And then I also have it give me any areas where it's, thinking there might be issues, even if it's like not certain that there's a problem, so that I can go in and then identify if there's something there or not.
So, Alex, it's a really good idea. The only thing I don't know how to deal with it is we will inherit human biases along. So how do you deal with that?
Well, that's the thing, is it doesn't end up making the final decision. It's just a first pass to say, okay, a patch like this was rejected for, X. Basically, it becomes these are the possible issues. Now it's up to a human to decide if these are actually issues or not.
Okay, sounds good.
Yeah, I think Sashiko is a much better candidate to put this thing in, because Sashiko is reviewing patches for every subsystem. And if we have something like a list of violated invariants, and Sashiko learns from all of that, that can be a common place which every subsystem can use, I think.
I'll give it to you, but I have a question. Do you guys name your AIs? Do you give them names?
Yes.
What's your AI's name?
My AI's name is Aiva, A-I-V-A.
Yours? What do you call your AI?
Vega.
Vega.
Abriga. So do you talk to it and say, Abriga, do this for me? Or?
Yeah.
Mine is called Angie.
I'm going to call mine Booba.
I kind of have a broad question maybe for the entire room. So Sashiko has been working for some time now. Have we noticed improvements as it analyzes more and more patches and gets more and more feedback? And is it noticeable and consistent, or is it still a hit or miss?
Where is Roman? Yeah, I was really looking forward to talk from Roman about Sashiko. He can answer your question the best.
Yeah. So.
If nobody has a question, I have. Which is your favorite AI?
He was just asking a clarifying question about whether I meant, has the kernel gotten better or has Sashiko gotten better? And I was asking about whether Sashiko has gotten better the more it reviews.
My observation is got a little bit more polite. So there's two Sashikos, by the way. I don't know if I should call. Do you guys know there's two of them? One is using Claude, the other one is using Gemini.
Oh.
And one of them is very polite. It doesn't point you to, this is my observation, okay? It doesn't point you to pre-existing bugs. Yes, it will pass your patch even if there is a pre-existing bugs that you did not cause by your patch. The other one will just goes on and on and on. So, someone help me out. Which one? Is it the Claude one or the Gemini? Claude is nice. Okay. Claude is the one who's, okay, yeah, you didn't cause this. But I honestly like the other one because I think I can do follow-up patches after that. All right, sorry.
Yeah, I'd like to mention one of the things that Claude Code is doing for me. So it actively also reviews me as an engineer, and it takes notes of what I'm telling it to do, where it thinks I'm lazy, where I am slacking off, and where I need to work on. So it is actively creating a profile of me and engaging how to work with me more effectively. So it is auto-loaded in the context, and that's what helps me.
So I guess we have winners, right? Claude and Gemini for AI, or no? There are more. GPT. Come on, what happened to? I know, but there is Microsoft Copilot. There is OpenAI ChatGPT. There are others. Grok. Anybody played with Grok?
I use it. I use Grok while I'm driving the Tesla. It's very fun.
Yeah. I never argue with my car. The car is always right, except while parking. It's wrong.
I think the cool people all use Opus.
Okay. We got lots of excited people downstairs. Let's give them a chance. All right. Okay, so we're waiting for Roman still.
Since I have the mic, I can ask another
question?
Yes,
go ahead.
I have one for Yuan. It's regarding the dashboard that you were showing. So I have a question for Yuan about the dashboard that you were showing. I was wondering whether you could make a system where you have the AI just pick different bugs that were found and try to create full chain exploits with the goal of seeing if it can discover new exploit methodologies. And so that can be then fed into the kernel as mitigation. So for example, what we have done with the slab allocator with obfuscated pointers and things like that. So kind of use, because the bug fixes are localized, but what if you could take each of the bugs to come up with new exploit generation techniques and then feed that back in as exploit mitigation so you eliminate classes of bugs altogether?
You are talking about generating exploits from this bug?
Yeah, so like use the dashboard that you have as a source of bugs and then chaining them together to see what kind of exploits, full chain exploits it can build.
Oh, actually, we haven't tried to merge, put together a lot of bugs to get one exploit. A lot of exploit we discover is only from one bug. So I'm not sure how it works. Maybe my teammate can help. I'm not an exploit guy, so.
I have an example of the case that you are saying. So the same bug class, copy fail bug class. It's not new actually. The copy fail bug class started in 2016, and we have I think now 8 to 10 different exploits. The unique thing about that exploit is it's not traditional. It's not memory corruption. It's not race condition. Nothing. It's a logic bug, but still it is a bug class. So to your point, it's very, very hard to chain, because when you chain bugs like this, it's actually you're chaining Wi-Fi or networking subsystem to, let's say, another bug in I/O Uring. So keeping the context of that far subsystem is very hard, but whoever does that gets another copy fail.
Yeah, I believe I've never seen chain bug except for the copy fail, right, in the kernel. Is there any more bug like copy fail?
Yeah, the copy fail is a bug class. Like dirty pipe, then dirty frag, then fragnacia, then copy fail 2.
Yeah, I mean copy fail. In copy fail we need a chain. We combine two bugs.
Right.
But in most of the cases we don't need that. Only one.
Most of the cases we don't. Correct.
Really, don't you need some information disclosure with some read primitive, then escalate that into a write primitive? It's generally chained.
Right, but those are usually in the same subsystem. Okay. Chaining is when you chain a different subsystem to a different bug in another subsystem. That I also think rarely happens. Most of the time, all of the entire chain lies in the same periphery.
Okay.
Yeah. That sort of goes against what you said, though, in your one of the slides. You had a mention of one full chain exploit going from the browser into the kernel all the way. So that's by necessity a whole bunch of different systems, right? So I mean, it seems like it's possible, but maybe it's just cost prohibitive.
Yeah, that bug we are used to change to exploit Android is using a Firefox bug and a curl bug. So we chain them together, so we can achieve the URL attack.
New startup idea.
Is there a preferred model or provider that for any of you guys? Is there one that you always go for, or do you always have a smart one that you pay more for and then go for? How do you approach this?
You mean first model? Actually, at first, our pipeline, our Vega is based on Codex. So, but in the future, we may use our own model. We may train our own model, I think.
But your workflow or your pipeline, do you go by some model initially and then keep improving on it, or?
So it's.
Do you use a specific model that you prefer, or a specific provider?
It's all Codex. It's all GPT.
All ChatGPT. Okay.
For me, it's all Opus series.
Opus.
Yeah.
And Opus for me and Fable 5.
Okay.
And did you made any research around the context size?
Which side?
Context size.
Context management.
Yeah.
Yeah. We haven't tried. We actually we are trying to speed the files into smaller parts and trying to connect the, some connected functions using some core graph or something. Yeah.
Do you use Cloud Code?
Me?
Yeah.
Not much.
Because Cloud Code has very good extensions, and they do basically the same thing that you will have to do, like offloading context from the context window. There's one called context mode. That extension is amazing. If you have a 1 million context window, it lasts at least 10 times more with that extension.
Okay, thanks.
That I personally use. So.
And Claude also has this claude.md and .claude directory from where it loads the context. So I maintain an index. So based on the task that I'm working on, it loads specific files which are relevant for the context. So that helps me manage.
Apparently Roman has been found. Don't lose all hopes. So we'll just get him for a very brief moment. Do people have questions for Sashiko? We won't let him present. He just answer questions or make statements. What do people prefer?
Questions.
Questions? Okay. All right. As soon as he joins, let me know. So we're extending the break a little bit just so that he can join. Is he on? He just joined. Okay. Can you put him on the screen, I guess?
Hi. Yeah, thank you for having me. And sorry, I was caught off guard, so I was expecting that like my talk will be like in 2 hours. So I was preparing to drive to Bay Area and present from there.
Yeah, it's okay. So Roman, we kind of ran out of time here, so we are not gonna. I know you're gonna present, but we're gonna do a slightly different format. There's questions for you, and maybe you can answer those questions. Yeah.
Sure, sounds good.
Okay. All right. Who wants to go first? All right, go.
Yes, so one question is, Sashiko, like how do you verify the output of Sashiko? That's the first question. Like Sashiko proposes a fix. Before sending that fix to the maintainer, are there any verification mechanisms?
Okay, so like kind of, there are two questions in one, right? Like first, Sashiko is not providing fixes, right? Like it just performs a code review and actually mostly asks questions or points at some issues, right? It does not provide fixes, even though some people asked about putting in some functionality, which is this functionality, but I have uneasy feelings about it, at least at this moment. So regarding verification of code review, I always relied first on the kind of benchmark I built very early on, which is based on the set of upstream fixes and corresponding bugs. So I just took like at that moment, like several months ago, I took last 1,000 completely unfiltered fixes in upstream with patches with the fixes tags, and using AI, I built a list of corresponding bugs, their descriptions, like initial commits which introduce these bugs, and I asked Sashiko to review these original patches and verify whether it can spot this exact same issue. So, and I have various like benchmarks of various size. My main benchmark is has around 1,000 bugs in it, and I use it systematically to develop Sashiko. And like the current reading with Gemini 3.1 Pro is around like 54%.
And
discovery rate.
Oh, and Sashiko keeps track of all this context. Like you feed this context every time. Like how Sashiko learns from all these things.
I mean, there is no continuous learning yet, so it's something I'm kind of thinking about. Right now, there is a set of prompts which many people which initially was created by Chris Mason and then developed by many folks, including networking folks. I think Jakub made significant contributions. So basically, it's a set of prompts which is developed by people right now directly, but what I'm increasingly thinking about, and I was about to present on this, is I'm thinking about trying to build an agentic pipeline to analyze the feedback from humans on individual patches and findings when like Sashika is sending reviews over email and people reply and saying, hey, no, this is like false positive, or like, oh yeah, confirms that this is an issue. And we can hopefully analyze this agentically and kind of improve prompts in sort of automatic mode.
Thanks.
Anybody?
We had another question about Sashiko improving.
Turn it on.
Hey, I have a question about whether you've noticed Sashiko's review quality improve the more it reviews.
I mean, the quality is a kind of it's a hard thing, right? Like at least for me, it has at least two main parts, right? Like first is like how good it is at discovering bugs. This part is relatively stable for last several months, and honestly, I expect next big jump will happen when we'll just get a better model. But and the second part is like false positives rate, which is way harder to measure. There is no kind of direct way to measure it, so I only rely on human feedback and some sort of statistics, right? Regarding false positives, I think Sashika got better over last, I don't know, couple of months, and just overall, like Sashika is 4 months old right now, which is, I think, pretty young, but I think it's easy to miss this. So there were some significant improvements in like how Sashika works, and, so I hope it minimized false positives. There were some specific bugs, but also now Sashika records on each stage dismissed concerns, and also it records specific places in the code and specific code snippets which back up their theory, and it uses it all in later stages. And I mean, there are some other ideas how to improve it. Like there are some limits of this, like kind of there is model, there is harness, and there is prompts, and all three parts contribute a lot. So each part has its limits.
Thank you.
Any other downstairs? Any questions?
None yet.
So Roman, yeah, another good point that was discussed before you joined. So which was basically improving the semantics of AI generated analysis. AI is good at mostly syntactic type analysis, which is like if you are analyzing a bug in one subsystem, it will try to grep for other similar stuff for in that subsystem itself. But like how about it can learn from each subsystem and apply that logic in some totally different subsystem. So one of the points which was discussed, like keeping a kind of a knowledge base of semantics of each subsystem that maintainers can help generate, and that we can feed into Sashiko, so that the next time Sashiko finds like reviews some bug in other system, it already knows like the subsystem, what type of intent the subsystem has, the code style, and all of the repetitive type stuff.
Maybe, yeah, it's kind of, as I said, like I always was relying on this benchmark or eval. The problem is like there are many ideas which look great. And like, I'm not saying this idea won't work, but like just as an example, like at some point I decided, I knew that Sashika is kind of less good with locking issues. And I said, hey, what if Sashika could, before jumping into reviewing a specific code, actually study the locking scheme in the particular file or like subsystem and build like a mental map of like how locking works in bigger picture, and use this information later in review. And I built it, and it looked great, like, nice. But it did not improve the discovery rate at all. And I also tried to kind of build a sort of a continuous learning system, and Sashika kind of records non-trivial things it discovers kind of as a byproduct of reading and reviewing code. And I was thinking, hey, again, like it will accumulate this knowledge, and we can fit this knowledge into context, and like hopefully Sashika will better understand the kernel. No.
Okay, so I'm going to try and wrap it up here because the other session starts in 10 minutes. Any last words of wisdom? What's your plan? What's tips for optimizations?
No, I think for me the main point is like the CI tools, they made Sashiko, but not also only Sashiko, like made a great pass in last really few months. Like 6 months ago, it was I wasn't convinced that it's possible at all, but now it's a fairly big thing, and they rely on your feedback to be improved. Like so, like if nobody is using them or nobody is reporting results, like they can be improved. So please provide your feedback, and that's the most valuable thing for us to improve it. Thank you.
Yeah, thanks, Roman. I'm sorry we didn't give you enough time, but we ran out of time. Okay, everybody.
Yeah, thank you.
Thanks, everybody, all the speakers, Roman, and everybody else.